Okay, do your animals have the maximum space that they need or that they deserve? In this lesson here, we're going to talk about building a pen for an animal. In this particular case, it's a rabbit. And we're going to model the story with a table, a graph, and an equation. I'll show you where we can put a graph. We're going to identify key features of a function. We're going to answer the question, are all quadratic functions increasing, and are they all discrete? And we talk about what the difference is between discrete and continuous. Discrete means like whole numbers. Continuous means we can have partial numbers, so decimals essentially. That's the difference between. So we get a pen and we want to build it for Rascal, okay? We have 72 feet of fencing, that stands out, and we want to build a rectangular pen. So we use this information here, or the space here, and what I want you to do is I want you to come up with 3 possible scenarios for a rectangular pen and write down its dimensions. Now remember, what do you know about a rectangle? Opposite sides are the same, opposite sides are parallel, 90-degree angles. So essentially what you're going to do is you're going to draw a rectangle, okay, it could be any random rectangle, and just put dimensions to it so that you're using all 72 feet of fencing. All right, so go ahead and pause and do that, and then come back. All right, so you're back. Hopefully you drew these. Well, some of the dimensions that were talked about in class were 25 and 11, 26 and 10, and 18 and 18. Now remember, all sides are the same, so we got, or all opposite sides are the same, excuse me. So if the top is 25, the bottom is, if the right's 11, the left is, and so on, accordingly with all of these. And we get all different kinds of scenarios that happen here. Well, what are we looking at? Nobody this year had come up with the smallest size that we could use, or shortest size we could use, and longest dimension we could use. And if we go ahead and, this is not, that's why I didn't do it. I was wondering what was going on. If we come up with that dimension, it's going to look like this big long rectangle. And if it does, we have the shortest dimension of 1, and we'll keep it with whole numbers. It could actually be shorter than that. And we'd have the long dimension here would be 35. Now, I'm just going to play the advocate here and have you notice something about all of these that you didn't, and I got a couple of ahas when I did this. If I take each of these rectangles that you all came up with and I cut them in half, 25 and 11 is 36, 18 and 18 is 36, 26 and 10 is 36, 35 and 1 is 36. And does it make sense? Well, you're using half the material for half of the figure. Both halves are the same. So yes, it makes sense. So what I'm going to do is I'm going to use that information to be able to come up with a formula for any of my particular dimensions. Now, if I increase this length from 1 to 35, if I increase it to 2, and that's kind of hard to see there, if I increase it to 2, what happens to this length here? It goes from 35 to 34. Well, how did I get to that 34? Keeping in mind, I'm only utilizing half of this. Well, let's go back. If half of this is 36, how did I get to 35? Think, how did I get to 35? If I know half of it is 36, oh, that's 36 minus 1. This would be 36 minus 2. And likewise, if I keep increasing it, if this goes to 3, then this goes to 36 minus 3. So it goes to the figure number minus 36, or 36 minus the figure number. That is how I get the other side. Keep that in mind because we're going to use that later. Now when we look at filling in the table, I want you to go ahead and look at the length and width. Well, the length is 1, the width is 35. Remember, how do we get that? 36 minus 1. And the overall area is length times width, which is 35. That's just a simple area problem. Remember, area is equal to length times width. Well, if I increase that to 2, that's 36 minus 2, or 34. What's the area? The area ends up being 68. And if I keep going, 36 minus 3, and you see where this is going, 33 is 99. Look at how the area doubles just by increasing it from 1 foot to 2 feet. Okay, so what you need to do is you need to go through the rest of this, and you need to put in all the possible sides. Okay, you'll bottom out, and I'll just tell you, you'll bottom out at 18. All the possible widths, do the first difference and second difference, find the total area, and do that and then come back. All right? So now that you've done that, you have all of this filled in. This should be 18 by 18, which is 324 feet. You should have a second difference of 2, I believe. Yep. So 2, 2, 2. And it should be a difference of minus 2, I believe, all the way through. All right? So you should have all that. This should be plus 1, plus 3, plus 5, and so on as we go up. Now it says, write a model for the rectangular of the pen in terms of the length of one side. Okay, so we have an area, we have a length, and we have a width. Well, go back and look at how did we determine that length and width. If my length is 1, my width is 36 minus 1. If my length is 2, it's 36 minus 2. If my length is 3, it's 36 minus 3. So 1, 2, and 3 represents the figure number. So if 1, 2, and 3 represents the figure number, okay, then all I need to do is replace that 1 with an x in this case, because it says x f of x. So I'm going to replace that. My length is going to be x. My width is going to be 36 minus x. And there is my multiplication. I put that second term in parentheses. So this is going to be x times 36 minus x. And it has to be, because 36 minus x is how I figure that out. So it says write a model in terms of the area. There's your model. Okay. Now, if you want to distribute, go ahead. You're going to get 36x minus x squared, or you could write that minus x squared, that's important, plus 36x. All three of those are the same. So, what kind of function is this? Well, obviously it's quadratic. Okay? Is the function discrete or continuous? Remember, what's the difference between discrete and continuous? Okay? Could we go in half-foot increments? We could, so I would say that it's continuous. Okay? What makes sense given the context? Well, we're using feet. Feet can be done in inches and so on. What is the domain and what is the range? Well, the domain is any number between 0 and 36. Okay? Now, why is it 0 and 36? Well, let's go back and let's see if we can find a space to graph this. I just need a blank piece of paper. All right? So here's my blank. I start off at 0, 0. Okay? The x value represents my length. Okay? This represents my area, actually. Okay? So my length in terms of area, my length goes from 1 to 18 on my table. But remember, if I take and I keep going past 18, I gotta go back for this, sorry. If I go past 18, what is next? 19 is next, but what happens to this over here? It goes back to 17. And if I go to 20, it goes to 16. Notice you have all of that up here, it's just reversed. Well, this can continue and go all the way until my figure is reversed and then it ends up looking like this, where you have 1, okay, it started off like this, okay, horizontal, now it's vertical, and you have 35. So that's how it would end up. All right? So domain is 0 to 36. Okay? I start off at 0, I go to 36. That's half of the fencing. The range, on the other hand, should be from 0 to 324. Right? Because 324 was the maximum number. If you go back and you look at your table, look at what's happening at your table. It's increasing, 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 increasing. And you get to 18. And the prior one I think was 323, if I remember right. Yeah, so 323, before that it was 320. So it gets closer and closer, but it maxes out at 324. On what interval is the function increasing? Okay, it's increasing, and I'll just put an arrow going up. You write increasing. It's increasing from 0 to 18. It's decreasing from 18 to 36 is what's happening. Does the function have a maximum or minimum? This one's going to have a maximum. And what are its coordinates? It's going to be a max at 18 and 324. And what is the equation for the line of symmetry? The equation for the line of symmetry is x equals 18. Sorry about that. They're doing some stuff. I don't know what they're talking about. How does the function compare to the second type of the block and eye rule? And we'll finish this up. The first difference is linear. In the rabbit run and the eye rule, it's also linear. The second difference is constant. And it's also constant over here. The graph of the rabbit run. Ooh, come back, come on, come back. Come on. It's being picky on a Tuesday. The graph increases, then decreases. This graph just increases for the eye rule. Okay. The equation. Both of them are going to have an x squared. That's how we know they're both quadratic. And then the last thing it talks about is the domain. Okay? The domain, it's continuous, but the domain is at 0 and 36. Okay? It's restricted. Remember, domain is my x values. Okay? So if we go back to where my deal is here, it stopped at 18. Well, gee, it goes all the way to 36. So my x's start at 0 and go to 36. How about my range? My range is from the bottom to the top. Well, it only starts at 0, and then it would go like this. Here's my axis of symmetry. Okay, it would go up like this, and then it would come down and meet over here at 36. So here would be my max at 18 and 324. That would be my max right there. All right. You actually have, if you look in your book right here, on page 42, you have a spot where you can put this. So I suggest you go ahead and pause and jot that down. All right. So pause me, jot it down, and then come back. All right. We're going to finish up here real quick. All right. Domain is continuous. Over here, I'm going to say the domain is 0 to infinity, because when we look at the eye rule, you kind of keep going. You start at 0, and you just keep counting the x values for however many blocks are in there. This one it's going to stop because we're limited. We're limited on the amount of fencing that we have. All right, and then the rabbit pen does not need to be If the rabbit pen does not need to be a rectangle, is there a way to get more area with 72 feet of fencing around the perimeter? The answer to that is yes, but be in class. If you want that, I'm going to save that for class. Is this a quadratic function? Yes. And why? Second diffs. All right. What other notables are there? We have a max at 18. It's a parabola. Okay. We could, well, let's just do a max. Let's just do this one. I have some other stuff in my notes. Max at 18 and 324. So there's my max. The domain is 0 to 36. The range is 0 to 324. A couple other notables and we're done. Okay. It increases from 0 to 18. It decreases. That's horrible, Mr. Wilson. Give me a second. It decreases. Sorry. Wow. 18 to 0. The x-intercepts. The x-intercepts are 0, 0, and 0 and 36. You can see that right down here, 0, 0, 0, 36. We'll see how those play back into our equation a little bit later. The graph is continuous. All right, those are just all some notables. There might be a couple more in there, but that's it for this video. Okay, ask questions as you need to.